Let's go to Encoded 2060. Check if an origin string exists given two encoded strings. The question gives us two encoded strings S1 and S2. Trying to see whether they have the same origin. But let's take an example of the example 2. Let's say S1 is L123E. And we can find, for example, something like a lead code. And we have L to be the first character. And 1 is here. And this is 2. And this is 3. And E. Let's say lead code can be the first string's origin. Let's say this is not unique. And you'll see the second one, 4 and 4. We can put this one as 4. And this one to be 4. So for these two strings S1 and S2, we find there exists such a origin, so it will return true. So so for this question, what we are going to do is that for these two strings S1 and S2, S1 and S2, we're going to use some kind of variable so to be index 1 means we already iterated the positions in string 1 and also index 2. The position x2. And in the position of x1, we are going to, this is the index of the encoded string. It will have a corresponding index of the original string. For example, we call it index 10 original. And there is an index of in the original string for the index 2. So I'm going to use another variable called diff. What be the difference between these numbers? So so if we use it, we are going to use the DFS to iterate this kind of index, and the differences. We just need these three states, trying to see whether it returns true and false. When we iterate those kind of numbers, it is possible some of the combination it already been calculated. So we can use a memo to store these three numbers. Of course, we can use a three-dimensional array to store it. But the convenience is that we can compose this one as 3 as a string, for example, this, and to concatenate as string. So let's write the code. So going to have this one converted to char array. And going to use a DFS array 1, array 2. We have the index of the in the first position, first string, and also index, and the diff current element. But the diff is 0, and I'm going to put a memo. Memo, we are going to use new hash map, as well as we will compose the three values into a string as a key and a boolean. So our DFS function will be array 1, array 2, int index 1, int index 2, int diff. I said this diff can be positive, it can also be negative. Hash. This will be the string in the boolean. Wait a minute. So I say let's look at the string key equals index 1 with more and concatenate this one as index 2 plus and plus diff. I say if this memo already have the value contains key suggestion. If the memo already contains this key, we just return array1, array2, index 1, index 2. Any issues? Contains key. Key. Just return mem with key. It should have a return result. Otherwise, so then we should return. Okay, let's get string 1's length and string 2's length. And we need to look at some of the exit conditions. So you will say if index 1 equals n and index 2 equals m, I have the Boolean result equals should have the diff equals 0, and we should put memo put key result and return result. So this is one of the exit condition. Another condition is that if index 1 is already equal to n, and if smaller than 0, that means I already finished because that means this kind of condition does not satisfy, then it move here. That means index 1 is already n, but index 2 is smaller than m. It's not finished yet. So we'll say, but this diff is smaller than 0, so it will, of course, will not have such as origin. So we'll say memo key false, return false. The same thing for index 2 go to end. If index 2 equals m and if greater than 0, we'll put memo put key false and return false. So this three will be our exit conditions. So let's iterate the possible combinations here. The first scenario is that at index 1, and it is digital, for example, 7, and it is possible some kind of digital after, for example, 6 and 3. And for this kind of digit 7, 6, 3, we know it have 3 different combinations. It can be 7, it can be 76, it can be 76, 300, 763. So we need to we use a number 1 here, trying to see different combinations of number 1, and trying to move the index 1 to here to compare. So let's write code. We have int number 1 equals 0. I say for int I equals index 1, I smaller than n, and if it's integer, yeah, if it is digital character is digit I, I plus plus. So we iterate the combination of number 1 equals number 1 multiplied by 10 plus array I minus 0. So for the possible n1 number, we have equal EFS array 1, array 2, and I plus 1. If this one, we already calculate index 2. Let's say we have the diff here, and for this kind of scenario, we calculate the combinations here for this digital, and as we have conditions, the number of consecutive in S1, S2 does not exist straight, so we can just iterate all the combinations here. Then we have diff plus number 1, and if it is too big, it will, this number if too big, this kind of calculations, it will may go out of time. So it will be returned true. And we also put this one as a memo put true. So we'll say if we find a combination which will return true, then we return true. But if we did false, it may have some other combinations go to that step. So we cannot return false right now. But if we return true, we don't need to calculate the rest. So the same thing for number 2, that is in index 2, it is a digital. For example, 2, 763 for index 2 S2. So this is the digital. For this kind of case, we just copy this code. We have index 2 equals 0. In I equals index 2, I smaller than M, and this is array 1, this is array 2, and this is array 1, this is array 2 minus, and now we are iterating, this is 2, and we fix the index 1 and move I for one step in S2. And for this one, we are going to use the minus 2. Okay, so this is another scenario. So that is index 1. Here, this is a digital. Here, the second case, that's index 2. Here, this is a digital. Um, so, so, um, so those scenarios that is either index 1, index 2. Here, they are digital. And there is some other scenario that is, for example, if we iterate, for example, here at the index 1, and here at the index 2. If this is not digital, this is a lowercase English character. We have, for example, this is a lowercase in character. We move this one step forward, trying to see whether we already have the combination. Calculate for index in the index 2 plus 1. So well, we can write this kind of code here, but we need to make sure that the diff is greater than 0. In that case, we can use the DFS can be iterated one more, and we have the diff -1 in the inner DFS, the next layer of the DFS, because so that it is a shrink function. Because if this one is smaller than 0, that we move one step. This one, the difference will get absolute value of the difference will get larger. It's not a shrink function. So we write code here. So if greater than 0 and index 2 smaller than m, and I say it's not digital. Array 2 dot index 2. Here we cannot use character is alphabet because for example, character A, it has a related a digital number like to be 87, right? So if we use its alphabet, it will be wrong, because like 87, those kind of number, it will return true. But here we do not want this one to be digital. 87 is it is, if we use the alphabet, it should not get this condition correct. So we have Boolean result equals DFS array 1, array 2, index 1, index 2 plus 1, and the diff -1, lemma, and the key lemma put the result return result. And we have another one that is if this difference is smaller than 0, and index 1 smaller than m, n smaller than n, and this one is not digital. result. So this one we move one step, and this one will be add one. The absolute difference is smaller. And get this kind of scenario is that index 1 or index 2, they are not a digital, they are lowercase English character. And the last case is that if equals 0 and index 1 smaller than n and index 2 smaller than m, and both of those are English characters. So let's say this one is, we'll copy this, and this one is also a case English characters. Here, let's say Boolean result equals array1 index 1 equals array2 index 2, and DFS we can move one character. If I say here the difference is 0, and if this character does not equal to this character, so I say the rest part would they of course return false, because the rest part it does not form, because the first character is not the same. It cannot be the same origin. So let's say so this is the first condition. Second condition is the array index move one forward. Array 1, array 2, index 1 plus 1, index 2 plus 1, and if we still have mem, and we have memo put the result and return result. So after all of these combinations is that anyone over digit, if this one greater than 0 and this is character, and this one smaller than diff is smaller than 0, this is the first part is character, and if difference is equals to 0 and both are characters, if we iterate all those combinations, let's say mem put in false and return false. Line 7 hash map. Any other? Okay, so this is correct. Let's take some of the other test cases. Okay, so this is a question